Station Houston on Space to Ground 2. Just a heads up, we're about 30 seconds out from PAO event. We'll be starting on time. Copy, thumbs up. Station, this is Houston. Are you ready for the event?
We are ready for the event.
KTRK, this is Mission Control Houston. Please call station for a voice check.
Station, this is Brianna Connor with KTRK. How can you hear me?
We hear you loud and clear. How us?
We hear you guys as well. You ready?
We are ready.
Here we go. We like to think eyewitness news is out of this world, and today we are proving it by having two astronauts currently on board the International Space Station join us to talk about how things are going and what their daily lives are all about. We've got Tracy Dyson and Mike Barratt. First off, I'll ask you, Mike, tell us about the path that led you to STEM and eventually NASA.
Well, it's a good question. I think I followed a similar path to a lot of us in the astronaut office, and that, we're all kind of fueled by curiosity and have diverse interests and really think about the future of whatever field that we really love. For me, I went through my career anxiety starting in high school, and I wanted to be an oceanographer and then an astronomer, and eventually went into medicine and really loved Earth observation. I loved flying, and guess where you can put all of that together into one place, one integrated, wonderful party, and that's at NASA. So I think NASA is built for guys like us, guys and gals like us who are curious and just interested in a lot of things and want to see that all do something positive for the future.
Yeah, Tracy, tell us a little bit about your path.
Well, I was in high school when I took my first chemistry class, and I was hooked. I loved chemistry because it answered the questions that I had at that point my whole life. And simple things like, why is the sky blue? Why does water boil? What's the difference between a tree and a bush? Those kind of things. And so I then decided to pursue chemistry in college. And then it was through my work in chemistry there that my advisors encouraged me to go to graduate school and to study chemistry even further. Along the lines of like Mike was saying, career anxiety. When I was a junior in high school, I was trying to think about what I wanted to do, and at the same time, the world was, or our nation really was buzzing over something NASA was doing, and that was putting a teacher in space. And for the first time, I really hadn't thought much about what these astronauts were all about. Just from the right stuff. I thought they were all test pilots in the military. But when I found out that they were sending a teacher into space, it got my attention because in high school, your teachers, you have not just one, but 6 of them probably throughout the day. My teachers were my coaches, my counselors. They were my mentors. They meant a lot to me. And so to see a teacher going into space as an astronaut was really motivating. And like Mike said, being the curious beings that we are, I looked more into NASA to see what they were doing, and at the time they were flying shuttle pretty rigorously, but they were also designing the space station, and at the time it was called Space Station Freedom, but it was not long after that they were transitioning to the International Space Station where we are now. And to make a long story short, once I found out about astronauts and what they were doing on the International Space Station, I made a list of things that I enjoyed doing, and it seemed to match everything that was going on at NASA. So that was kind of the path I took, both with chemistry as well as with NASA.
Yeah, I know what it's like to have a curious mind, but journalism was a little bit better of a fit for me. Mike, I want to ask about the experiments that y'all have been working on up there on the ISS.
The experiments are very, very diverse. You know, we do everything from fluid physics to combustion science to basic biology. And a lot of my favorite ones are the human medical experiments, because we become such interesting creatures up here. But I'll highlight one that I'm part of, which is the Cypher experiment, which you know, every system in the body changes as it adapts up here, which is pretty neat. But all of those adaptations are interdependent on one another. It's a global change, a holistic change. And Cypher is a package of multidisciplinary medical studies that tries to correlate all the changes from one system to another. So what happens in the cardiovascular system might relate to changes that we see in the neurovestibular system or the immune system. So I am one of the subjects of this from my background standpoint, and my familiarity and friendship with that community. I think that's probably one of the more special things that I get to do, and I'll be doing some of that right after this. We'll be looking at my retina, and we have a technique up here we call optical coherence tomography, which takes really detailed looks at the back of your eye, all the layers in there, and the powerful tools like that up here enables us to really push the boundaries of physiology, especially in this novel environment.
Wow, that is fascinating. Now, this next question is for you, Tracy. As a vet on your third space flight, what, if anything, has been different or surprising this time around?
Well, there's, I think, two things that stand out to me. One is during my previous missions, we were assembling the space station, and using the space station as a laboratory was just in the infancy of our program. And so coming back now, and the assembly is complete, and we are full throttle on utilization and science and technology and demonstrations. It's really been a joy having a science research background to come here and do science, and as well as take care of the space station. So that's one of the big differences. And I think one of the other pleasantly surprising differences, although I don't know how many of my crewmates would agree, is that the place is a lot more organized than the last time I was here. And now it's, you know, because we were constantly building the space station, and it was changing, and we hadn't quite really, after 10 years even, figured out what we needed to make this a well-oiled machine, and we were still learning. And enough of us have lived up here for 6 months or more, and we've come back and fed our ideas back, as well as all of those that work on the ground to design and operate and help control this space station. So we've pulled into our creative minds and have really developed a more efficient machine up here, from everything from cargo operations to stowage to how to operate the systems on board the space station, and makes a lot more room for the science to happen.
I could see Mike's face. It certainly looked like he agrees with you, Tracy. Now, we know NASA is working to get astronauts back on the moon with the Artemis mission. So if successful, Tracy, how do you think that'll shape the national conversation about the merits of space exploration?
Well, nationally speaking, I think we're standing on the shoulder of those that made the Apollo program happen, and so there's that level of confidence that we know how to get to the moon, and but this time we're going not just to see if we can get there, but to see what we can do once we're there, and to sustain our missions at the moon. But I think as what makes it a conversation in our own nation is the international, the global, the fact that we're going as planet Earth. We're going in a partnership fashion back to the moon, and with I guess social media being what it is, and information spreading like wildfire, not just throughout our nation but our whole globe. I think everyone's going to be talking about it because everybody's going to be involved, and I think everyone can see themselves in some form or fashion being a part of it.
Yeah, Tracy, I think you're right. Now, Mike, we know this is your third trip to the ISS after previously going into orbit in 2009 and 2011. How has each trip differed for you? Has it gotten better each time?
Well, you know, each one has its own character. Again, I kind of look through a medical physiological lens. When you take your first flight and the engines cut off after ascent, space starts talking to you real quick, and it reminds you you're in a novel place, And you feel that in ways like your sense of balance goes off, so you may get some space motion sickness. Your body fluids redistribute, so you may get some head fullness. You have to learn to navigate in 3 dimensions, and believe me, people on their first flight tend to bump into things quite a bit. That's just scratching the surface of it. But your second and third time, space talks to you, but your body starts to talk back, and it says, I've been here before. I remember this. I'm familiar with these conditions, and you adapt quicker. And I certainly did that on this third flight, even though it had been a 12-year gap. So I found that fascinating in and of itself, whether there's something innate that just remembers the zero gravity, or whether it's just thought through cognitive strategies. But there is something about repeated flights that make it much easier to pass through those inevitable wickets of adaptation up here. To me, that's actually one of the most interesting aspects of spaceflight. I love being up here. I love floating in zero gravity, and there's a lot more wonderful things that go with it. But it's a pretty magical place, and it was great to get back.
It certainly sounds like it. It definitely looks like it. Finally, I'll ask you, what is it that makes you want to continue going up into space and learning more?
Well, we've been going into space now for several decades, and I can honestly say we've still only scratched the surface of what there is to know about systems and how they work in space and how the human adapts to space. And I can say that with confidence because we keep finding new things, big things, physiologic effects that were right in front of our faces for years, and we just didn't see them. And when you have a laboratory that's well-staffed and well-equipped, you're able to find things like that. And, we will continue to discover and explore things like crazy if we only stay in low Earth orbit. And some of those are helpful to us on the ground in our understanding of basic science. But a lot of them are important in the next steps that we want to take. And to me, that's probably of the greatest interest. When I talk to kids a lot, and often they will say, well, when we go to Mars, we will do this. Or when we go to another star, what will it look like? It's almost an absolute inevitability to them, whether it's the sci-fi culture or the vigorous activity of spaceflight right now on so many different fronts. It's just assumed that we're heading that direction, and that's this generation that's coming. And I think building those stepping stones to get our civilization out a little bit further and really learn about our spaceflight environment, to me, that's the biggest magnet.
Hands down, I think I can say this is the neatest conversation I will have all day. Mike, Tracy, thank you so much for joining us and for your really interesting insight.
It's our pleasure. Thanks so much for your interest and your questions.
Station, this is Houston ACR. Thank you. That concludes our event.
Thank you to all participants. Station, we are now resuming operational audio communication.